All right, let's do a demo. We're going to use Monte Carlo simulations to determine when a particular item is going to be done. So when am I going to get my stuff using Monte Carlo simulations? So we're going to start off with a pile of items. This is basically our product backlog. And it's a simulated product backlog. There's not a lot of detail to this, just a bunch of item names and the number that item is in the backlog. So someone comes up to us and says, when is item O going to be done? Item O, that's item number 15 in our backlog. So rather than thinking of this as when is item O going to be done, a better way to think of it using throughput is how long is it going to take us to get 15 items completed. It doesn't really matter about item O. There's nothing magical about that. There is something much more significant about delivering 15 items. So you'll start by figuring out what your throughput was over the last 6 weeks. And let's say it looks something like this. Week 1 was 5, week 2 was 7, week 3 was 3, week 4 was 5, week 5 was 22, and week 6 was 6. Now you might be thinking, well, what if I don't have any historical throughput? That's, well, less awesome, but I'll show you how to handle that a little bit later. Don't worry about that for right now. Let's assume you have that historical data, and I'll show you how to start with nothing later on. So Monte Carlo simulation number 1, roll 1. So you're going to roll a dice, and let's say that you get the value of 4. So now you're going to take the throughput value for week 4. Throughput over the last 6 weeks. Week 4, the throughput was 5. And now into simulation number 1, and that question that we're going to answer in simulation number 1 is how long will it take to deliver 15 items? Now week 7 of that simulation, which would be, let's say, the next week, we're going to take that value from week 4 because we rolled a 4, and now week 7 we're going to simulate it as a throughput of 5. Total throughput now becomes 5 for simulation 1. We need to deliver 15 items, and 5 is less than 15, so we need to do this again. Simulation number 1, roll number 2, roll the dice again. This time we get a 2. So we're going to take the throughput value for week 2. So over here, week 2 was 7. So now, week 8 becomes simulated throughput of 7. So our total throughput now becomes 12. 12 is, once again, less than 15, and we're looking for how long will it take to deliver 15 items. So we roll a third time. Roll number 3, roll the dice, we get a 3. We take the throughput value for 3. Throughput value for week 3 was 3, put that into simulation 1, and that becomes week 9 as 3. Total throughput becomes 15, and hey, 15 is equal to 15. We wanted to forecast how long does it take to deliver 15 items, and in this simulation, it took us 3 weeks to get that done. Next, do this 999 more times. Yeah, it's a lot. All right, so let's say that we did simulation number 2. We repeated that same process we did before. We kept rolling the dice and picking a throughput value for historical throughput and adding it in to our simulation until we got something that was greater than 15 on the total throughput. In this case, it took us 5 weeks, 5 rolls of the dice, to get to something over 15 throughput. In this case, 5 weeks, we got 20 items done. So comparing those two simulations, remember we're doing random simulations of how these throughput calculations could go for 15 items. And for simulation number 1, well, we chose the way that we have worked before, using historical throughput values, and it took us 3 weeks. We did it another way, and it took us 5 weeks. Does that kind of feel like how software development works? It's kind of, sort of, right? Like you think you know how you're going to do it, but sometimes there's a lot of variation. So anyway, you do that simulation 998 more times, and yeah. Here's what it looked like for me when I did 1,000 simulated outcomes. And I grouped it together by how many weeks it would take to deliver 15 items. So that first column, number of weeks, that's how many weeks it took to get 15 items of throughput. The frequency column is how often out of 1,000 simulated outcomes did it take 1 week, 2 weeks, 3 weeks, 4 weeks, or 5 weeks to get 15 items. Probably makes sense to try to visualize this in a graph. So taking those 1,000 simulated outcomes, sometimes it took us 5 weeks to deliver 15 items, but that didn't happen very often. It only happened 8 times out of 1,000. But we've got this big, gigantic, very common outcome, which was 3 weeks. It sometimes took us 1 week or 2 weeks or 4 weeks, but, well, Let's try to figure out what the percentages were for those. How often did we get that outcome? Got it all done in 1 week? That happened 16% of the time. That's not nothing. That's not totally unlikely. 2 weeks, 13%. 3 weeks, 53.4%. 4 weeks was 16%. 5 weeks, 0.8%. So really unlikely that it would take us 5 weeks to get 15 items done. But let's figure out the likelihood. The likelihood that we get it done within 1 week is 16%. The likelihood that we get it done within 2 weeks is 29.8. And the numbers are getting higher, more confident as we go down. So 83% confidence that we'll get it done inside of 3 weeks. 99.2% confidence we get it done in 4 weeks. Just about 100% confidence that we'll get it done in 5. But how did we get those numbers? So what's the chance that we get this in 1 week? Well, that likelihood, the percent chance that we get it in 1 week, is 16.5%, which is the same as the frequency. And what we're doing is we're sorting this data in ascending order by weeks. So week 1, 2, 3, 4, 5, not 5, 4, 3, 2, 1. What's the chance we get this in 2 weeks? Well, the chance there is 29.8. So how did we get that 29.8 number? What we did is we added up the frequency for all those items above it. So 2 weeks and 1 week, what's the probability of those two things? That ends up being 29.8. What's the chance we get this in 3 weeks? 83.2. We got that by adding up the probability of 1, 2, and 3. So this is another way of saying we have an 83.2% confidence that we'll get this done in 1 week, 2 weeks, or 3 weeks. Basically, 3 weeks. Chance of 4 weeks is that total. Chance of 5 weeks is that total right there. And that adds up to be just about 100%. So back to that question, when are we going to get item O? Or how long is it going to take us to get 15 items? What we would probably tell our customers or our bosses is that we have an 83.2% chance that it'll be done in 3 weeks. I usually try to figure out what my 80% and 50% levels are, just because it kind of works in people's heads. So 83.2% chance it'll be done in 3 weeks. So that, I'd say, is probably very likely. There's a 30% chance it'll be done in 2 weeks, which is unlikely, but not entirely out of the question. But if you want to figure out with near total certainty, like we have to be absolutely sure we're done in that period of time, you start looking at things like this. Well, we're 99.2% sure that it'll be done in 4 weeks. And the difference between about 100% and 99.2 is not that much. So it's pretty darn unlikely that it's going to take us 5 weeks, but it could take us 5 weeks. But if you show this to your customers, your bosses, your stakeholders, they're probably going to understand these probability numbers. 83.2% chance we'll do it in 3 weeks. They'll probably understand what that means, and you could go in and explain the math to them if you need to. And it's all based on throughput.